Hi, good morning, everyone. Thank you so much for joining us today. And I hope you are keeping safe during this period and wearing masks, washing your hands, and practicing social distancing. We are not out of this yet, but we hope to be out of this soon together. And while we work hard to keep our physical selves safe, we cannot forget that these days we spend a lot of our time in the cyber world as well. Cyber terrorists and hacktivists are working really hard as well to steal sensitive information and compromise the security of our network. My name is Evan, and I'm from Exclusive Networks, and we are proud to carry two powerful solutions to your security issues. CrowdStrike protects your endpoints and devices from the growing threat landscape. It is not just an antivirus, but a security platform as well that hosts investigatory and visibility capabilities, among others. Sharon, if you can go to the next slide, please. Netscope 2 is a platform that protects your data in the cloud, whether it is at rest or in motion. It also provides you the visibility and control over user actions, as well as access in cloud applications. Today, we will be talking about how CrowdStrike and Netscope can work hand in hand to provide you a holistic and comprehensive security that leverages on the power and agility of the cloud. I'm pleased to welcome Valerian from CrowdStrike and Nicholas from Netscope, who will be presenting on each solution and how you can stay protected. Each solution overview will be followed by a demonstration so you can see and visualize how you can keep your IT environment safe and healthy. But first, allow me to show you a short integration video on the sharing of threat intelligence between these two technology partners. You see, by sharing forensics, Netscope and CrowdStrike can ensure newly discovered threats are quickly identified and the threat neutralized across your entire organization. Additionally, Netscope is able to granularly control the cloud access and activities of these endpoints. The CrowdStrike platform binds with the Netscope Cloud Native Threat Protection Engine and shares detected indicators of compromise, or IOC, to bolster Netscope's already robust malware detection in the cloud as well. Together, customers are given increased real-time, actionable threat forensics and enhanced malware protection on both endpoint and in the cloud. I'd like to pass this time to Valerian, who will be sharing on CrowdStrike first. Over to you, Valerian.
Thanks a lot, Evan. Let me share my screen. Hopefully you can see the screen now. Can someone confirm?
Yes, I can see your slides.
Excellent. So thanks a lot and good morning, everybody. Good afternoon, wherever you are. My name is Val. I'm the Solution Engineering Manager at CrowdStrike for Asia. And today I'm really pleased to join Exclusive Network and Netscope for that webinar. What I'm going to talk about for the next 10 to 20 minutes and show you with the live demo is
Hey guys, I think we've lost audio here.
Hey Val, I think you got cut off. There's something on your audio side that's having an issue.
I think I got muted. Yeah, I think I got muted.
Oh, we can hear you loud and clear now.
Yeah. So let me revert here. So the fundamental issue that we're trying to face and to combat right now is to stop breaches. And in 2019, we successfully managed to block or prevent 35,000 potential breaches. And I'm going to dive into how we did that and what we believe is, the solution to kind of stop that problem, to balance, the battle against adversaries. And our adversaries are strong. We are talking about Russians.
You lost your voice again.
Someone is muting me. I think someone is muting maybe all the participants, and I'm getting muted. Hopefully it doesn't happen again. So we are benchmarking the attackers with a metric that we call the breakout times. It's the time it takes to actually break in an environment and move laterally. So the Russian, in 18 minutes only, they can send you an email, you click the email, for example, or open the file, and you're compromised and they move laterally in 18, which means you need a technology that allows you to see through that and outpace them as fast as possible. You need to query all your endpoints and say, who ran PowerShell, RDP, SMB, SSH, and you need that answer to come as fast as possible, because otherwise you will never be able to exceed their pace or their speed. But this is the quality of the adversary today. What we offer at CrowdStrike with our next-gen NAV EDR solution is a venture into all the threat actors that we are tracking, and you have access to that. So here you can see we have a pretty large library of threat actors, and you can slice and dice the data to actually reflect your own threat landscape. As an example here, I'm going to focus on targeted country Singapore, and immediately I have an understanding of how many groups are tracked by CrowdStrike and attacking Singapore. There are 11 actors here from Russia, China, Eastern Europe, India, and North Korea, and their intent is either espionage, stealing some data, or criminal, more toward financial gain. For each of these groups that I have narrowed down that are really relevant to me, I can read on what is that specific group about, where they are from, what are the targeted nations, what are the targeted industries, but more importantly, what are the kill chain techniques and tactics and procedures, how do they behave? And that knowledge is very useful to tweak your security controls to make the environment stronger. As an example, this graceful spider was last active in June 2020, and then it was attacking different nations, and you can see here some of them are in that region, Southeast Asia, Indonesia, Malaysia. So definitely this group is pretty active here. And in terms of what they're using, so they test their tools against AVs because they procured them or they found a way to have them, and they are doing that. So it means that there is a large chance that your legacy AV relying on signature is not going to detect it because they are testing it. And signatures is by and large failing today because of the volume and the polymorphism and the complexity of the malware. This is where we actually had a different design. We believe from the first day at CrowdStrike in 2011, we don't want to do signature because in the long run, it's not going to work. We want to invest into machine learning and behavioral analysis, what we call indicator of attacks. The second elements that you could read on this group is using HTML attachments containing links to direct victims to Dropper documents. So do you think your email gateway would see that? Maybe some email gateway might be able to do that, but maybe not. So
Val, your audio is gone again.
Someone like muting all the participants and somehow I'm getting because my mic is muting and unmuting and muting and unmuting.
Hey Val, it's Brad Gray here from Exclusive. Sorry, you're right. I think, look, someone is muting all participants and that's turning Val off. So please refrain from doing so and let the Exclusive team manage the participants. Thanks, Val.
All right, thanks a lot. So on the endpoint, we can see through all these things because we don't really care about the delivery mechanism. All attacks start and end on an endpoint. So when the link is being clicked, when the browser is being exploited, that's where we're going to see it. Other thing that we can see is you can learn from this attacker group is they are using dynamic link libraries, which are pretty complex to detect with signatures, because usually they are highly polymorphic, and we have seen a lot of legacy AVs failing at that. Machine learning, threat hunting, and IOAs are very successful at that because they're not looking at the characteristic of the file or the signature, what is the file, but its behavior, how it's behaving, and what are the key functions and the key components. You could learn that this group is using HTTPS traffic on TCP port 443. Maybe you have, network threat analysis. Are you doing SSL decryption? No, then you would be blind to everything that this attacker is actually doing. But in the endpoint, we don't really care. We see the backdoor connecting. We see what the backdoor is doing. So again, it is the best place to be to stop threats, to have that rich data on the endpoint. And finally, because we do threat intelligence, we can inform you on the malware capabilities, on the threat group capabilities. We are aware of all the things. With that knowledge, you can actually go into all your security controls and fine-tune some of the settings or fine-tune some of the correlation rules or whatever you have in your environment to make it stronger. So the bottom line of all that is attacks are starting and ending on the endpoint. We believe that this is the best place to be to see what the attacker is doing and kick them off. And we rely on a multifaceted, multi-stage technology. For commodity malware and known TTPs, we believe that signature has failed. 1 million malware per day. How do you want to write 1 million plus signatures every day? Signature is not just a hash of a file nowadays, it's sections of the file. So it's not an easy process to write a signature of a file. And the volume has become so important that it is impossible for signatures to catch up. So what we built at CrowdStrike is a next-gen AV that is leveraging on machine learning and behavioral analysis, which is more powerful on the long run. For advanced CTPs, we believe in EDR, which is the ability to collect everything that is happening on the endpoint, surfacing malicious behavior or suspicious behavior for the analyst, and giving to the analyst the context to take a decision. Within 5 minutes, I see that suspicious behavior that is flagged by CrowdStrike. It needs to be vetted by an analyst, but the analyst can do that because all the information is at their fingertips. And the last tier of our solution is threat hunting. We believe that machine can help to make detection prevention better, to provide that context. But at the end of the day, if you are a threat and you have seen thousands variants of the same attacks, breaches happening, then this knowledge will help you to threat hunt at scale across many organizations and identify immediately when an attacker lands on a machine and is mimicking administrator activity or is very stealthy. That knowledge, we have it. So we have built that threat hunting capability with some of the best threat hunters on the planet. So if I take 3 examples for the 3 tiers of technology, machine learning is a bit of a commoditized word these days. So what makes a good machine learning engine? We believe that the quality of training is very, very important. And we were the first machine learning engine ever introduced to VT in 2016. So we have been training that engine for the past 5-6 years. We have access to samples that we can glean in our incident response practice. We have access to some commodity malware, obviously, but also state-sponsored samples. So we can train the model to recognize both commodity and APT grade trade crafts. So that's the power of the machine learning engine that we built. On the behavioral analysis, we believe that IOAs are superior to signature. And this is an example of an indicator of attack. A process executes, enumerate your files, delete your backups, and call encryption routines. This is a ransomware. We don't care about the file. It could be written in PowerShell. It could be written in, it could be an executable. It could be a batch file. It could be whatever. We don't really care because we look at its behavior. And all the ransomware behaves the same. They check if you have pictures, videos, documents. They delete the backup so that you cannot restore them. And they call encryption libraries that are available, or bring their own and start the encryption process. So at various stages of that execution, we can actually take a decision. During enumeration, if there is a spike of read, we could take a decision. Or when the backups are being tampered, we could take a decision. Or we could take a decision if the three are happening. But this is, on the long run, superior to signatures. Tomorrow there will be a new maze, there will be a new WannaCry, and we will detect them because we are looking at their behavior and not their signature. And finally, our managed threat hunting that we call Overwatch, they are expert at differentiating admin activity from attacker activity. When they see a PowerShell command or any command, they know that this is not an activity that an administrator would do. It looks like something they've seen before. It looks like something that the threat intelligence notified our threat hunting team, some advisories. But they have the knowledge because they have seen these attacks and thousands of variants of the same attacks many, many times. So this is that knowledge that allows them to actually threat hunt at scale. So another question I got a lot is, do you have an on-prem solution? Can you do that threat hunting on-prem? Can you collect all the data on-prem? And you might want to try that, and maybe you will need one server here, or a second one, or a third one. But the reality is you will need a full data center, each of you, to actually replicate that capability. And this is a reason that we built it in the cloud, because the amount of data that we collect in a week is the equivalent of what Twitter or WhatsApp calls. So we need the cloud because it's agile, it grows, it shrinks. We have the ability to do very complex cross-correlation analytics. And the only way is the cloud. The amount of data that is required today to stop breaches requires it's inevitable. On-prem will not give you, the computational power or the cross-correlation capability to look through all the threats and drive decisions. The second thing that we want to solve with CrowdStrike is agent bloat and signatures. In the past, whenever we wanted to add some new capabilities, we were adding a new agent, usually a new console, and we ended up with multiple agents, 12, 10, 15 processes, different console, siloed information, and we want to stop that. Our mantra, our tagline is single lightweight agent, single console, 1% CPU. So whatever we deliver it within a single agent, and we stop known malware, unknown, 0 days. We can do remediation, we do machine learning, offline protection, I mean, you name it. But we will always deliver these capabilities through a single agent. That is a very important thing for us. And with better performance, 1% CPU and 40 megs of memory. From a deployment perspective, it's very easy. There is no infrastructure setup. You install the agent, there is no fine tuning, verified installation, there is no reboot required, there is no signatures update, there is no scan, there is no spike of CPU, yet you get instant visibility and protection. Some of the organizations that have trusted us managed to deploy within a few days, dozens of thousands of agents, because this is very stealthy, right? This is a very transparent process. So whatever pain you might have had in the past deploying some endpoint protection, this is not something you will get. It's pretty seamless. So if I wrap everything together, you have an endpoint, and an endpoint could be anything. It can be an iOS device, could be an Android, it could be a Windows, could be Mac, could be Linux, could be in container, it could be in AWS, Azure, Alibaba, GCP, you name it. We have an agent to support as many flavors of endpoint as possible, virtual, physical, on-prem, in the cloud, because the attacker can be anywhere. And the way you consume IT, might be different. So we want to be everywhere. The first layer of defense would be machine learning, or file-based, known and unknown. We will have machine learning blocking, quarantining the files so that you don't have any consequence and you don't even have to investigate because it's blocked, it's quarantined, problem solved. Second layer, for fileless, we perform exploit detection and behavioral analysis. What's happening in the memory? Is there an injection? And so on and so forth. We try to look at these kind of patterns and block them if they happen. The third layer is living up the land. What we mean by that is whenever the attacker is using PowerShell, WMI, all these tools that are available, on Windows, Linux, or Mac, then we have built behavioral analysis to see when Adobe, when PowerShell, when Microsoft Office is behaving in a way that it's not supposed to behave. And then we take a decision to prevent it or to detect it. This is complemented by the EDR capability, which is essentially it's collecting everything that is happening on the endpoint. And data allows us to do hunting. And if you want to do your own hunting, you could do it, because at the end of the day, the hunting practice that we do is on top of the same data that you have available in the console. But because we have access to all this activity, we can do way more. We have a clear picture of the applications running in your inventories, in your environment. So we can do application inventory. Do you have torrent clients? Do you have Office? Do you have Adobe Flash, Dropbox, TeamViewer, Go to My PC, whatever it is, you can have a picture of that. Because we know the application and the versions, we can tell you that you have a vulnerable Adobe Flash, a vulnerable Dropbox, a vulnerable browser, or vulnerable operating system. So we do vulnerability inventory. We also see all the logons. Because we are on the endpoint, we can see what our users logging in. So we can do account discovery. How many local accounts, how many domain accounts, are they connecting through RDP or locally? Was the password reset recently or not in the last 2 years? So you have an understanding of that. And finally, we do assets inventory. What are the neighbors of the endpoints that we're installed on? If you look at it from a different, picture, this is what we provide with a single agent, many different flavors of endpoints, from mobile to cloud to on-prem, and we provide cloud security, endpoint security with next-gen AV, device control, EDR, firewall management, security and IT operation with managed threat hunting, hygiene, vulnerability inventory, managed remediation, and threat intelligence. And one important point here is we have a store, which means we can augment the capabilities with strategic partnerships. And this is where Netscope is coming into picture. And I'm gonna just elaborate on some of the things here. So if you take the leader in CASB and the leader in endpoint security, Netscope plus CrowdStrike, then you have a bespoke protection against advent threats that are moving to the cloud, that are on-prem, that are on the mobile, that are everywhere. So you can literally track down, hunt down the attacker, regardless of what they are doing, regardless of where the data is going. And that is a pretty powerful solution to block advent threats. There are mainly 4 use cases that are, powering that integration between Netscope and CrowdStrike. The first one is bidirectional integration. IOCs from CrowdStrike, threats from CrowdStrike are shared to Netscope, and threats from Netscope are shared on CrowdStrike. So with that bidirectional integration, we can actually see, from the cloud or the threat from moving to the endpoint. So we don't leave any blind spot where the data is moving, where the malware or the attackers are moving. The second use case, or here the fourth use case, would be about posture. You can have some policies to say, I don't want, the endpoint to access specific cloud services if CrowdStrike is not installed. So this is a good way to have some sort of network access control to kind of guarantee that you're not exposing some data when the endpoint is not protected by CrowdStrike. So there are many use cases that make these two solutions working together seamlessly and enhancing your security. So you can believe me or you can test it out. So, I could talk about CrowdStrike for hours, but what I really invite everybody in the call today is go on our website, submit the form, try our, next-gen AV, our EDR. We will reach out to you. We can have custom test cases for you, but try it out. We are battle tested. We are happy to be tested, and we will be honored to protect you. On that, if time permits, I would like to do a 5 minutes demo. Say again? Did you say something? So, can everybody still hear me and see my browser?
Yes.
Awesome. So, a 5 minutes quick demo of CrowdStrike. This is the console when you log in. Everything that you see here is populated through a single agent. You have all the alerts coming from machine learning, behavior analysis. It could be an IOC shared by a Netscope. It could be a different mechanism, but this is in a single dashboard. The first thing that you might notice here that is quite interesting is crowd score. Crowd score is the likelihood that you have hostile activity going on. So it moves over time. You can see the graph. And when there's something happening, for example, there is a WannaCry outbreak, a maze outbreak, this might go up. Or if you're fixing vulnerabilities, you're fixing gaps, it might go down. But you can benchmark your security practice with crowd score. The real meat of the application is under. Today, I have 223 detection. How can I go through so many detection in a day? Maybe I'm a one-man security shop. How can I do that? 220. We provide efficient triaging and filter. First thing is severity. I'm gonna, filter by severity first. So obviously I'm gonna go for critical alerts first. Then we also have the tactic and technique. So we are fully aligned with the MITRE framework. So we tell you that these alerts are pertaining to credential access, defensive evasion, command and control, exfiltration, post-exploitation. You can, based on that, more. And in my example, I'm gonna go because it is the most critical type of, let's say, alert that you could have, because it is actually, your data might be at risk. So for all these types of attacks, you can actually investigate faster the one that really matter to your business. So you would go then into your process tree. You would understand, what is happening. So everything is happening in real time. So you would see exactly what the attacker did. You could track them down and highlight, what are the things that make these behavior malicious. So you could read on here, this is a rootkit that we have detected here, but you could see everything. If you were to be in prevention, that's where we would actually prevent things. We would actually block the attack fairly early in the attack stage, because there are enough behaviors for us to take a decision. But here I'm in monitoring mode only to show you that. From there, this is more a next-gen, purpose. This is more on the EDR, on Linux and Mac and Windows, but there are much more in the platform you can get. We do full gaps analysis. So we look at what's happening in your environment, applications, assets, accounts. And this is pretty powerful because it gives you things that you could fix in your environment to make it stronger. So application inventory, you could find, compliance issue, security issues, cracked application, or license usage. There's many use cases. But here, you will get an immediate understanding of your domain accounts and your local accounts and see, for example, if there path that you see here, you could set in that demo environment, I have 72 domain accounts, 920 local accounts, and more importantly, we have 6 domain accounts that haven't reset the password for 1 to 2 years. And this is pretty critical because it means that the attacker could steal that password and use it for months before you actually, fix the problem. So by just simply fixing your red, orange, and yellow problems, then you would make your environment way more stronger against attacks. It's like closing avenues that the attacker could use. So that's our IT hygiene. We also provide device control and firewall management, but the one I want to show you now is our Spotlight capability, which is an inventory of your vulnerabilities. What are your vulnerabilities in the environment? Here we can see there are 66,000 vulnerabilities that are critical. You can slice and dice the data and see what are the browsers that are vulnerable, or what are the operating systems that are vulnerable. Or let's go into the servers. I want only to see, the servers. What are the critical vulnerabilities for my server 2019, for example? And I immediately end up with a view of what are these critical vulnerabilities in my servers. So we try to prioritize your patching practice. And this is scanless. This is happening on the endpoint. It's passive collection of the applications that are running or installed. And yet you get that immediate picture of your vulnerabilities. And once you fix them, your graph will reflect that, and you can really track down your patching practice. So again, single agent, vulnerability inventory, IT hygiene, next-gen AV, EDR, and managed threat. So I hope it gave you a quick, view into what CrowdStrike can provide. But again, I would say I would really advise anybody in the call, to get your own feel of the solution, how it could complement your existing security stack that you have. So you just have to go to our website or reach out to me or the CrowdStrike team or Exclusive Network, and we can make that happen. On that, thank you very much for your time.
Thank you so much, Valerian, for sharing on CrowdStrike. Before I pass this time to Nicholas, if there are any other questions, please feel free to type them in the chat, and we will answer them at the end of the session in a short Q&A session. Over to you, Nicholas.
Thanks, Evan. All right. Do you guys give me a minute? Do you see my screen?
Yes.
Hi. All right, cool. Good morning, everyone. I'm Nicholas. I'm from Netscope. I'm the Regional Director for ASEAN and Greater China. So today on the call, it's beside me, I have Cam, who will later be presenting demoing the Netscope. He's the Senior SE for Netscope, also based in Singapore. Today, I'm going to talk about is the visibility, data protection, and connectivity itself. So I think everyone knows what's happening right now, right? It used to be the good old days where we used to work from office, was able to communicate face to face, and suddenly with this whole COVID crisis, everyone just started using Zoom, Teams, and webinars to do presentations or meetings or discussions. So basically, everyone has kind of went silo to work from home, and yet business continuity still needs to happen. But this is what happened previously. As a IT organization, what they would usually do is they'll build perimeter defense around their environment or their data centers. And users basically will say that when I'm in office, when I'm going out to maybe my web or my cloud or my infrastructure, it's going to be on my perimeter defense itself. I'm going to defend you. I'm going to block you. I'm going to control. But, here is the new norm. Things has changed. COVID is here. Everyone is working from home, and everyone basically has brought their laptop or their mobile out of office to home. And, where is the data going? So this is what's happening right now. Your users basically have gone from in the office to remote with their laptops back in home, but yet the data is always, or the sensitive data is still sitting in their laptop. And it's no longer being defended by the perimeter defense, the firewall, the VPN, or the endpoints, or the IPS. It is directly to net. So when you go direct to internet, where is the perimeter right now? How do you defend a data from your user on the endpoint to the web, or to the cloud applications? Are they using your authorized company's OneDrive or Google Drive, or they could potentially be uploading it to a personal OneDrive? So a lot of things we have seen is the users tend to have a bad habit where they would just do a right-click share, but without knowing if they have logged on to their corporate or their personal OneDrive. On top of that, when they access the infrastructure, it is just directly from their office directly to a AWS or the Azure itself. So with that itself, the whole parameter defense that maybe the IT has spent millions of dollars on is no longer able to defend whatever that you thought about, or whatever that the users are doing right now when they're working from home. And this is where this endpoint becomes very vulnerable. And definitely that's where CrowdStrike comes in to defend the endpoint. But yet the data exfiltration or the data movements across the web, across the SaaS, across the infrastructure becomes become invisible to the IT or the organization. No one knows where the data is moving anymore. So with that itself, the IT or organization runs into risk. What kind of risk are you going to run into? Well, exposure is the first thing. Have you shared, or are you allowed to share this sensitive data to a specific organization or to the right organization? Have you misconfigured your infrastructure in a way that now users are working from home, they're accessing directly to the infrastructure? Have you done proper configuration to make sure that he or she is the authorized user into the infrastructure or into the data that you want to access to? Access itself is the next thing. Is your users accessing the data from the authorized approved laptop, or is he accessing it from his personal device? How do you know that? Then definitely from a disruption and from a theft standpoint, how are you going to control the users that could be accessing the data of the OneDrive from their personal laptop or their personal BYOD devices? That could be, having a malware. And when he or she upload the data to the OneDrive and share it to a third party or even to your individual organization, how do you know that the data is not malicious? Is there a malware sitting in that laptop? Is the hacker accessing it somewhere based on the user's credentials and accessing it from Japan instead of Singapore? So all of this become your new risk when your data is now sitting in a cloud, or your users are working from home accessing the cloud, and the visibility becomes transparent to invisible to the users. So with that itself, the next challenge that you're going to face is remote users. Previously, what you have done is you have allowed users to access VPN to your VPN concentrator to your infrastructure. This is what people are doing right now to give some form of parameter defense around it. Or they could potentially be saying that my users basically design a VPN concentrator where they'll hit my security web proxy or my parameter defense that I built in my organization back out to the web or back out to the cloud. Well, that is possible if you had like a couple of users, because your VPN was never designed to have all users, everyone working from home. So what really happened is that VPN concentrator right now has to take the load of 100% users working from home to access to your applications in the data center, accessing to the public cloud, or accessing back out to the web or the cloud. So this is where Netscope comes in play. Netscope basically, we provide a security cloud for remote workers wherever they are, whether they are working from home, BYOD, mobile phones, unmanaged devices. Basically, what we are doing is we are bringing the security that you have built on your parameter in your office back to the users when they're working remotely. So what we're doing basically is we have moved the user's security to the cloud. And we have placed like DLP controls, data protection, web protection, next-gen web protection for the web, for the SaaS apps itself, for the infrastructure, and for the data center itself. And one of the most critical thing that we do, which is patent, is we provide decode of APIs. What it means is that we are able to now differentiate if the users is accessing his personal Google Drive or a corporate Google Drive, or the Outlook.com, is it accessing to a Netscope Outlook, or maybe to exclusive Outlook. So we now differentiate it through our decode of the APIs. And definitely we work with the third parties like CrowdStrike to be able to give more in-depth security on the endpoints, or EDRs, or PAM solutions, or single sign-ons, where you need to do authentication to authorize the users to access back to the authorized application. So to go into details, this is where Gartner loves to categorize technologies into different categories. So from a CASB, this is where Netscope is a leader in this space. We are a cloud access security broker, which protects the SaaS application. So if you had moved your organization to the cloud for Office 365, or you're considering on it, but the security is your concern, this is where Netscope comes in to say, you have a pool of managed cloud applications. Maybe it's OneDrive, Box, Salesforce, but on the other hand, you have certain unmanaged cloud applications that you want to do controls. And Netscope basically will have 4 pillars of doing this. The first one is API. So from an API, it's pure data discovery. It's never real time. It's in reliance on what your supplier is giving to you, your service provider. So example, in Office 365, Microsoft will give an API out to OneDrive, SharePoint, Exchange Online, Teams, and we will basically have to take it in and say that I see this data that was shared to third party, or this data is used by this user, or who has uploaded the data. But on top of that, what we do is we go one level up to give you inline real-time controls. So from a managed device, now we are able to say that beside the Office 365, Teams, or the Exchange Online, now if you are using a Microsoft Forms or OneNote or any other Dynamic 365, we can give you real-time controls. From the managed device, we are now able to say that, hey, when you take this data from your corporate OneDrive and you download to your endpoint, no sending it to a Dropbox or a Google Drive or certain unauthorized cloud storages. Or on top of that, maybe your organization might adopt some cloud applications that might not have APIs. Then that's where we are able to say that all those apps that has no visibility, Netscope brings back that visibility. So it's a patent technology where we look into the data, into the traffic, and we say that, hey, you're using Zendesk. In Zendesk, we saw someone did a login, logout, who uploaded, who downloaded, where did he come in from. Our UEBA capabilities will kick in to say that this user logged in from Singapore, and within a minute, he logged in from Japan. So all of this is all being detected by Netscope. On top of that, we detect up to 33,000 cloud applications today. So we don't just detect and block. We are now saying that we detect, we enable if you need to. So this helps organization be flexible. Instead of buying the most expensive cloud applications, you might want to look for a lighter price, not so expensive cloud app, but yet being able to manage it. Now, on top of this, we move a bit more to the right, where we now also provide secure web gateway. We are a next-gen secure web gateway. So what we're doing is we're doing a proxy consolidation for your organization. Instead of building your proxy on-prem, now your users is able to bring whatever proxy design that you have placed in your organization out back into the remote workers working from home. So we are now able to say that with a single proxy for your cloud, your KSV, or for your secure web gateway, we are now able to say that the data that is going into LinkedIn or going to some web post will never happen. So we're never going to allow a user to say that I'm going to upload this sensitive data from a Word document, convert to a PDF that is online. So we can do all of this controls also on the web. Besides that itself, we provide cloud security posture management, where you start designing your AWS, your Azure, or GCP in the cloud, and you want to make sure that you're designing a secure infrastructure. You want to make sure that no sensitive data is left behind on your S3 buckets or your blob storages. You do not want to be the point of malware attacks, where hackers basically can leverage your AWS to be a point of malware. And one other thing that we could perform is we can give you real-time protection on your infrastructure. So what it means is we are able to say that, right, somebody is, can you kindly mute yourself? Hello. Yep. All right. Thank you. So on top of this, what we are able to do is we are now able to say that, hey, as a privileged user to my infrastructure, I might be a DevOps guy accessing your AWS or your Azure. But in the event when I start taking that infrastructure and shut it down, or copying that data from your AWS S3 to a personal AWS, Netscope is able to detect that, and we are able to stop the privileged users from doing abnormal activities. And we will have a workflow to say that in order to do this, your CIO must be the authorized user to do a stop of services or start of services. Your job is purely just working off the infrastructure. So we can now give privileged users access controls, not giving them the freedom to do whatever they want. On top of this, we are now able to give you private access. So instead of having that VPN concentrator that you had designed to support maybe 20% to 30% of your remote workers, Netscope now gives you private access, where we basically host like a VPN. But on top of that, we don't do IPsec or SSL, where you have to do IP planning in your organization, VLAN planning, where your data from your users remotely must come back to a certain VLAN before going to your application. What we are doing is our zero trust network access basically allows users, based on the authorized user, his credential based off of AD, now can access specific applications. So it becomes lightweight, easier to deploy, and because it's hosted in the cloud, Netscope basically has the performance to support the users. So with all of these capabilities, here comes performance. So we always make sure that we have data centers spread across the globe to support your users remotely wherever. So in Southeast Asia, although we have our data center sitting in Singapore, peering it to all your cloud providers, what we have is connectivity between the telcos in country back to Singapore. So with that itself, the latency between the service providers is less than maybe 60 milliseconds. On top of that, we have GTM. So in the event, if your users could be sitting in UK, Hong Kong, or wherever, they will hop on to the nearest data center that is maybe in UK, and you'll connect back to the cloud applications because we're peering. So by and large, the way Netscope is designed basically is we talking about all of this is not a very complex design. We could potentially have a single agent that is connecting your users to your applications on-prem, your private cloud, your public cloud, your cloud applications in your SaaS and your web. So all of this is all controlled by one single agent, one console, and the agent do not perform anything. It is just pure steering. It does not consume any processes on your on-prem, or sorry, on your laptop, and it's just pure steering. It steers the traffic and to Netscope, and Netscope basically is doing all the performance in the cloud. So we always make sure that our data center does not consume more than 20% of the CPU. So the workload of the data center is pretty stable and strong to support users. So definitely with security, with user experience, performance, and simplicity, it's easier and it's scaling on demand for you guys itself. So the last part before I end it off to Cam, who's going to do a demo, is here is the value proposition of Netscope with CrowdStrike. From Netscope side, what we are able to do is today we are able to say that we are able to scan the OneDrive or the cloud storages, and we are able to say that, hey, when we saw a certain abnormal malware or certain bad file, we are able to inform CrowdStrike to basically say that, hey, we saw this in the cloud. You might want to look out on the endpoint to find if that malware is sitting on that endpoint. On top of that, we could take in the IOCs of CrowdStrike and send it into Netscope so that you have a central threat where Netscope and CrowdStrike has the similar threats. And we are able to say that now that we scan your OneDrive or your cloud storages or your web, we are now able to say that we saw the same hasher, the same threat detection that CrowdStrike has, and it's basically able to be in sync in that sense. So all the bad files are basically being detected and removed on the whole. So I've come to the end of the whole Netscope presentation. I'm going to stop sharing, and I'm going to hand it over to Cam, where he will now do a quick live demo of the Netscope technology.
Thanks, Nick. Can you all see my screen?
Yes, Cam, go ahead.
Yeah, hello everyone. My name is Cam, Regional Pre-Sales of Netscope. So in this demo itself, I would like to share with you on how Netscope Cloud Security Platform is able to secure access to your company private applications, the websites, and also the cloud applications and services. So there are three parts in this demo itself. First, we'll cover the Netscope Private Access, the Zero Trust Network Access solutions, followed by the visibility and risk assessment of cloud apps and your web usage, and finally, the granular policy enforcement. Okay, in this Netscope Private Access demo scenario, I have a few private applications and services or servers that are actually located in my public cloud infrastructures, AWS, and also in my corporate private data centers, right? Okay, using Netscope Private Access solutions, I'm able to allow secure remote access from the remote workers to each of the individual applications itself, the internal applications, based on the user's role and job requirement. Okay, so before we start assessing those, we will need to make sure that the NPA solution wasn't in place, so that when we actually try to access some of the internal applications, they are all not successful. Okay, we try the SSH, we try RDP, and we will try to access some of the internal applications, the intranet itself. Now let's enable the NPA client, our agent itself on the endpoint, and private access is now enabled. Now let's look at the SSH access itself to the internal Red Hat server. It is successful. And we can also do a SFTP using Fuzilla, try to do some file transfer. And now we will try to RDP to a Windows servers hosted in AWS. All right. So the user's access, its experience is transparent. And we can also access these applications, web applications, that is for server and network monitoring. is also hosted in the AWS itself. Okay, so now this is in the private, your corporate data centers using IP address. So your access to these internal applications is all seamless. You can use internal FQDN. You can also use IP address. So all the access logs is being captured, right? You can see these are all the access from the, say, the users itself to different applications. You can look at some of the metadata and stuff like that. Okay, so that's pretty much on the NPA. The next demo, it's about how we are dealing with cloud app and web usage and how we are able to monitor those access and assess the risk from there. So let's start off by performing a series of activities on some of the cloud applications, both corporate and personal instance, right? So this is a corporate Office 365 instance. I'll try to log in and then do a file upload itself. After which I will log off from this instance. Okay, this is a corporate Office 365 instance. Okay, I'm uploading a file and currently I'm logging out from it. Next, I'll do the same, but this time it's on a different Office 365 instance. It could be a partner or personal instance itself, doing the same upload of the same file. Next, I'll do it on G Suite, right? Google Drive, and I also have a corporate instance of this. So what I'll do this is to download the file, right, from a corporate one Google Drive, then upload to a personal Google Drive, then upload to another instance of Google Drive itself. I'm going to share it also to an external Gmail address. And here I'll try to use my personal webmail and then send out the file that I just downloaded. So same thing on a personal Dropbox. I upload that file, go to AWS S3 buckets. And over here, I'm going to my EC instance here in AWS and try to stop running VM itself. So now let's see what we captures in our console, a series of events that we captures. So based on the set of a series of activities that the user has just performed. So we can see we captures things like, login attempt, login successful to a specific instance, trying to upload a specific file to that instance, and a different OneDrive instance doing the upload itself, going to a Google Drive, upload a file, sharing a file, using a personal webmail. These are all the things that have just been performed. And this is all the metadata, the events logs that we captures on our web GUI. So very detailed informations from who, timestamps, the login account, things like that, right? So this is for the Dropbox activities, the applications, the instance ID, the URL, and all kind of informations, right? So we also provide dashboard for our customers to basically zoom in to each individual users. What are the applications they actually access throughout the timestamps of like last 30 days, 7 days, or 90 days. So we can click on each of the applications, look at the usage, right? Okay, look at the events as well. If you want to, we can zoom into the raw events. We can look at the websites that they access as well. And also we are able to link it up to whether the users has triggered any anomalies, like what Nicholas has mentioned just now. Users log in from different locations within an hour of time. So those are the anomalies that we are able to detect, and as well as the whether the users triggered any DLP incidents, whether they download any malware has been blocked, and actually visiting any malicious sites. So those are the informations that we actually captures, right? So in the home dashboard, right, we can actually change the timestamps of the period of time. We can look at how many applications of the entire organizations the users access to, applications, the websites, number of users, right? And we also have the widgets that you can configure, put it up on the box itself, that summarize all different kind of data like policies, triggered, top 10 users, and so on. So from there, you can actually zoom into an application dashboard. So this basically shows all the applications, the cloud applications or services that the entire the users of the organization is accessing to, right? So it shows all the shadow IT, whether it's a sanctioned instance, unsanctioned instance. We also group them into different categories. Like each category, how many applications of the same categories is being in use and who are actually using it, right? From here, we also show the CCI, the Cloud Confidence Index. So it's a risk scoring features to kind of assess how enterprise ready application is. So in this example, WeTransfer is having a very low CCI. It means that it's a high risk applications. So we can click on that and look at the activities, who are the users that's been using these applications for file transfer purpose. We can zoom into the raw events if we want, and we can have look at all the others related incidents. So we can click on the CCI of that applications and zoom in to see why this application itself is rated so low in the CCI, because we have this 50 over criteria that we use when we are doing the assessment of this particular cloud application itself. So things like whether it has audits, it has a legal, whether you have enough data disaster recovery facility, doing enough data protections, and stuff like that. Right? So if we click into the CCI, the library, so this Cloud Confidence Index, we have actually done research on over 33,000 of cloud applications so far. Okay, if you click on any of that in the database itself, you can do a study of that applications, what are activities that Netscope can capture, why this application itself is being given a 96 score, which is quite a high score. And this shows this box is a very enterprise-ready applications. You can also do a side-by-side comparison of the two if your organization is planning to use some sort of cloud storage. Okay. Yeah, so with the visibility itself, okay, then it helps you to assess your risk and using the data-driven approach to build your compensating policies. So in the next demo, we'll show you how we can do some policy control to compensate some of the security risks. So in this example itself, I will do a very simple approach here. So I'll basically configure two policies. The first one to allow all kind of file uploads to corporate instance, right? The Google Drive and the Office 365 OneDrive for Business. So the first policy, I'll allow all this to happen. Then I'll have the second policy that blocks all the cloud storage file uploads. So in the DLP profile, there's many of these templates that we already built out of the box that our customers can use. And in terms of actions, there are things like encrypt, quarantine, block, allow, things for options for our customer to choose from. Okay, now we have the policy in place. So I have some sample PII and PCI data that I can use to test out. So in terms of the corporate instance of G Drive, the access is allowed it hits the first policies, and this is basically the personal Google Drive, and it's blocked by the second policy. Okay, I can even go in to test out things like the Dropbox where we have tried just now. So this is also blocked by the second policies. Okay, next, you can also configure more policies for social media control, right? Users going to Twitters and, accidentally put in some PII informations, or going to personal webmail, try to put in some of the PII information stuff and send out using their personal webmail. And that also can be blocked by our policies. Right, so on terms of websites, we have the capability of doing the form post DLP control as well. And we can also configure policies to control unauthorized shutdown of a specific VM in the AWS or even in Azure. Okay. So next, we also have the capability of machine learning by identifying or detecting screenshot, passports, photos, as well as credit cards and the social security cards as well. So in this example, if you are doing a normal screenshots of files, an image file, it goes well because it gets uploaded. But if you are doing a passport, we are able to detect it and we block it. Right. Likewise, for screenshot, we can do the detections and do the blocking. Okay. Yep. So the next thing is to basically based on the CCI level, right? For example, we want to prompt user alerts when the user is trying to access things like very low or poor CCL. And then we will warn the users. And we can also block users from going to undesirable websites, URL category filtering. So we have all these built-in categories that you can use out of the box, depending on what sort of website that the organizations wish to block itself. So next things, we will do the testings here to show this user is going to Yahoo Mail, which is a very low and not so secure web-based email, a free webmail. Okay, the users can provide justification and proceed if you want to allow them to do so. So WeTransfer is also a very high-risk file transfer programs or applications. So now user is going to gambling websites and it will be blocked by our policies that we have configured. Right? So the next things we're going to do is about malware protections, right? Upload, downloads to all the kind of websites. So in this case, right, we configure the two policies. One is going to a malicious website. The other one is the malware upload and download. Now let's do some testing itself. We go to a sample malware websites, try to download ones, being blocked. And this one is from a personal cloud storage, download malware, get blocked. And this is a phishing email trying to make you visit one of the malware distribution point and you get blocked by Netscope. And this is basically a sharing of the malware itself, right, coming into your corporate mailbox. And when you try to open it, it gets blocked by Netscope as well. Okay. So same thing if we the users unintentionally uploading some stuff that they're not aware is basically a malware to their corporate OneDrive, and it gets blocked. Okay. So we have a different set of dashboards that actually allows our customers to look at the alerts, the policy violations. Yeah, we have the DLP incidents dashboards, right, that show you all the forensics, why these transactions, this event was blocked. And we have the anomalies that look at, potentially data exfiltrations has taken place. Okay, we have the behavior analytics dashboard as well, looking at each user's scoring, rescoring. We have the malware dashboards of which are the malwares that's been detected, right? And we can go in, take a look at how it was detected as a malware. We have the cloud sandbox, how it was triggered, detonated, and whole change of events. Yeah, and here this dashboard for users visiting the malicious sites itself, right? Or can serve as the point of investigations. All right, so with that, I'll end my demo here. I hope you have a good, quick glimpse of how Netscope is able to provide that kind of visibility and control that you need in order to safeguard your access to the website, to the cloud applications, as well as your internal private applications. Thank you.
Thank you so much, Cam. Okay, now we are in the Q&A section. Please feel free to put in your questions. I will be reading out loud a couple of the questions that have been asked earlier. So this is a question to both CrowdStrike and Netscope, right? So when it comes to your solution, which OS can you protect? Operating systems. Valerian, would you like to go first?
Absolutely. So we support all Microsoft operating systems that are still supported by Microsoft. So you could think of Windows 7, 8, 10, and all the servers as well. On Linux, we support some of the more widespread Linux. You could think of Ubuntu, CentOS, Red Hat, Oracle, Amazon Linux, and some others, as well as macOS, iOS, and Android. So that is, yeah, the OS support.
All right. So from Netscope side, we support basically the Windows, the Mac, the Chrome OS. From the mobile devices itself, we support definitely the both OS. Yeah, that's basically it.
Thank you, Val and Nicholas. So when it comes to a subscription, a pricing model, is that something that you can elaborate a little bit on, and how so for the benefit of our end users and partners here, how does that work?
So for CrowdStrike, it's per endpoint and per model. So depending on your needs, right, you could go for, I don't know, next-gen AV, EDR, and hunting, or you could add on top of that vulnerability inventory and hygiene, and we're just gonna calculate the number of endpoints and per model. So yeah, per endpoint and per model.
All right, from Netscope side, basically it's based on 80 users. So if Nicholas is one of the 80 users and he has 3 devices, we still deem it as a single license. But the main thing that we charge is on the modules itself. So example, like if you were to use our CASB or our web or our infrastructure or even your private access, we basically charge based on users on those modules. The only one thing that we follow closely with is the infrastructure, where people like AWS or Azure will charge you based on your number of EC2s, your number of storage size. We will base on that to reduce complexity, because charging users doesn't make sense for infrastructure.
Thank you again. Just quickly going back to the agents again. When it comes to, so you mentioned iOS and Android, so tablets and phones will be protected as well. What about the different flavors under the Linux OS? Is there any, is there any restrictions there? Val, would you like to answer that?
Yeah, I think that was more from Nicholas. On CrowdStrike with support, like Ubuntu, Debian, CentOS, Oracle, Red Hat, Amazon Linux. So yeah, this is some of them.
Okay. Yeah, from Netscope side, we don't really have any agents on the Linux OS because those devices are not really work from home. However, what we can do is we can use reverse proxy concepts for those Linux OS. If you are accessing certain authorized cloud applications itself. But by and large, because the Linux are more for server-based requirements, we don't really look into that. It's more for work from home or mobile users itself.
So that in a way also answers the one of the questions that we have about not for Netscope not using an agent. So we am I right if we're using a reverse proxy, Nicholas?
Yeah. So we have we do manage and unmanaged devices kind of setup. From a managed device, we can either use an agent or we can use a pack file. Or we can even, if you're in the office, we can use IPsec or GRE steering on your firewall, on your router. So if agent is always a concern to some organization, then we have all these alternatives. But reverse proxy will be from unmanaged devices where the user is saying that I'm accessing from my own BYOD device or some unauthorized devices. Then they hit upon my organization's OneDrive. Netscope will have a reverse proxy based on Samuel redirect. We will be able to pick up that user and say, although you're authorized, but you're accessing a corporate OneDrive, I'm not going to allow you to do a download. You can work off the web or the cloud, but no downloading of the data. So that's what we can do for reverse proxy. But from a reverse proxy standpoint, we do not support web or private access. Private access is like a VPN where you do need to have some form of agent to steer traffic back.
Thank you, Nicholas. And another question to you, Nicholas, is Netscope considered a SASE?
Yes, we are a SASE. I did not use the term SASE in this webinar is because a lot of customers still have not really fully adopted the mindset of SASE. So a lot of times when I present it, I try to explain the technologies behind SASE. But yes, by and large, we are a SASE. Since the topic SASE was brought up, for those that do not know it, it's actually Secure Access Service Edge. One thing you need to understand from Gartner's topic of SASE basically is saying that SASE means that I'm going to give you security with performance or without any concerns of latency. So what we do is we build that 50 data centers. It's owned by us. We don't sit on AWS. We do not sit on a GCP. So everything is all co-hosted by us. We sit in tier 1 data centers where there is multi-telco links back to these tier 1 data centers. And with that itself, we provide each of our data center easily has 10 gig pipe, and we're able to support the intake of traffic. So SASE basically means that I'm building this whole big infrastructure around the cloud and yet giving you security around it.
Thank you, Nicholas. And this is a question to Val. Could you talk a little bit more about? Oh, okay. So you have answered the.
Yeah, I can take it. Yeah. Just in case, we are running out of time, I wanted to answer here. So yeah, CPU and memory usage of CrowdStrike, so it's very low, it's very transparent, 1 to 2%. There is no spike, around 40 megs of memory. So the idea is we didn't want to replicate, some of the mistakes from the past, some of the other vendors. So we wanted it to be completely transparent unnoticeable for users, for productivity, and especially on servers. We don't want to disrupt any business application. So definitely extremely low footprint.
Thank you, Val. And we're just moving to the last question. So to Nicholas, you talked about securing through the Active Directory. Is there any existing recommendation or previous use cases that we have done with Active Directories?
Yeah, we have done with, even in Malaysia, one of the telcos in Malaysia uses Netscope, and we hook in with their Active Directory. So when we say Active Directory, it can be your on-prem Active Directory, or you could be running an Azure AD in the cloud. We support all of them. So yeah, it's not an issue. We can also support schemes. If you are having some IDP, which is a scheme 2.0, we will support it too.
Thank you, Val and Nicholas. Okay, we have come to the end of our presentation. For those who are here, thank you so much for joining us today, and thank you for listening in on these security solutions. We'd love to continue this conversation with you in person, and we hope to reach out to you as well, and also talk a little bit more about in more detail about how our solutions can be deployed and configured in your environment. This is the end of our presentation and meeting. Thank you all. Take care and stay safe. Bye.
Thank you, everybody. Have a good week.
Thank you all.
Goodbye.